Today, we're diving into a group of chemicals with a pretty dramatic and honestly dangerous double life. They're called organophosphates. And their story? Well, it's a story of both saving lives through agriculture and ending them through warfare. Let's get into it.
It just sounds wild, doesn't it? The idea that something we use to protect our food could also be one of the most terrifying chemical weapons ever made. So how on earth can one chemical be both a helpful tool and a horrifying toxin? That's the big question we're going to get to the bottom of in this explainer.
All right, so to really wrap our heads around organophosphates, we've got to look at the two completely different worlds they live in. One is out in the open, on our farms. The other exists in the much darker world of conflict and terrorism. And this really lays out that split personality perfectly. On the one hand, yeah, they're absolute workhorses in farming. Pesticides, herbicides, you name it. But on the other hand, they are the literal building blocks for some of history's most infamous nerve agents. We're talking sarin, VX, and even the more recent Novichok agents. It's the same basic chemistry, just with two vastly different and chillingly opposite goals.
You can see this whole story play out right here on this timeline. They were first cooked up in a lab back in the mid-1800s, but it wasn't until the 1930s that we figured out, hey, these things are amazing insecticides. But then, just a decade later, during World War II, the German military had a much darker idea and turned them into neurotoxins. And that dark path, as you can see, continued right into the modern day with terrorist attacks and even state-sponsored assassination attempts.
Okay, so we've got the what. But what about the how? How do these chemicals actually do what they do? To figure that out, we have to zoom way in, down to the microscopic level, and watch as they literally hijack the human nervous system. It all comes down to this one molecule, acetylcholinesterase. Let's just call it ACE. It's way easier. The most important thing to know is that ACE is the off switch for your nerves. See, your nerves fire signals using a chemical messenger called acetylcholine. Once the message is sent, ACE comes in and cleans it up, which turns the signal off. It's absolutely essential. And this is what that process is supposed to look like. It's super clean, really efficient. A signal comes in, acetylcholine gets released to carry that message across a tiny gap, the next cell gets the message, and then, and this is the key part, ACHE cleans it all up. On, off. Simple. It's what's happening in your body millions of times a second for every single thing you do. But when an organophosphate shows up, this entire elegant system gets completely sabotaged. The poison molecule literally latches onto the ACE enzyme and just breaks it. It's completely blocked. So now that off switch is gone. With nothing to stop it, acetylcholine just builds and builds, flooding the system and hammering the receptors over and over again. The signal is now permanently stuck on, and the entire nervous system goes into a catastrophic overload. So all that chaos at the microscopic level, well, it doesn't stay microscopic for long. It explodes into symptoms you can see all over the body. It's like the body is screaming a series of alarms, and if you know what to listen for, you can decode exactly what's gone wrong inside. And this quote here from the source material really nails it. It mentions a cholinergic toxidrome. Now, that's just a fancy medical term for a very specific set of symptoms. It's all caused by that flood of acetylcholine, overstimulating two key types of receptors in your body, nicotinic and muscarinic. So let's break those down. First up are the nicotinic effects. Think of these as affecting your muscles and your fight-or-flight systems. You get these uncontrollable muscle twitches, that's what fasciculations are, which can eventually lead to total weakness and paralysis. At the same time, your heart starts racing, your blood pressure skyrockets, your body is just spiraling out. And then you've got the muscarinic effects. These are the ones you might have heard of, and they're often remembered with the mnemonic dumbbells. This is basically all of the body's glands and smooth muscles going into absolute overdrive. All the taps are turned on full blast. We're talking sweating, urination, pinpoint pupils, drooling, crying. The body is essentially leaking from every possible place. Now look, all of those symptoms are absolutely horrific, but they're all leading to one single catastrophic outcome that is the main cause of death here. You can't breathe. It's a triple threat. The B in dumbbells, bronchospasm, means your airways are squeezing shut. At the same time, they're filling up with fluid. And on top of all that, the muscles you use to breathe are becoming paralyzed. It's a complete shutdown of the respiratory system. But here's the thing. It doesn't have to be a death sentence. There is a way to fight back, but it is an absolute desperate race against the clock. Emergency rooms have a very clear protocol they follow to try and reverse this poison's devastating attack.
First things first, decontamination. You've got to get the poison off the person so it stops being absorbed. Second, and this is critical, you secure the airway. That's the most immediate threat. Third, you hit them with a drug called atropine. Think of atropine as a shield. It blocks the muscarinic receptors so that flood of acetylcholine can't do any more damage. And finally, you bring in the true antidote, pralidoxime, also known as 2-PAM. This stuff can actually reboot the enzyme, the ACHE. But, and this is a huge but, it only works if you give it in time, before the poison forms a permanent bond. That process is called aging, and once it happens, there's no going back.
But even if you win that race, even for the people who survive that initial terrifying crisis, the fight is far from over. This poison can leave behind a long, lingering shadow, causing some really debilitating health problems that can pop up days, weeks, or even years down the road.
One of the scariest delayed effects is something called intermediate syndrome. This happens about 1 to 4 days after the poisoning, so just when everyone thinks the worst is over, a whole new wave of muscle weakness hits. And frighteningly, it can progress once again to life-threatening respiratory failure.
And the damage doesn't even stop there. Weeks later, survivors can develop things like peripheral neuropathy. That's numbness, cramping, loss of reflexes. And there's also pretty good evidence of long-term neuropsychiatric issues, memory problems, confusion, lethargy, even psychosis. The attack leaves these deep, lasting scars on the nervous system.
And this right here, this chart tells a tale of two different worlds. In a place like the US, with tight regulations, you can see the number of cases has been dropping. But globally, it's a whole other story, especially in the developing world where these pesticides are cheap and easy to get. Pesticide self-poisoning is a massive public health crisis, causing up to 370,000 deaths a year. It's a horrific tragedy, and it's born from just how available these poisons are. Which brings us right back to where we started. But now the question feels a lot heavier, doesn't it? We've seen how a chemical made to help can be twisted into a weapon. We've seen exactly how it tears the body apart from the inside out. And we've seen the two completely different realities of its impact around the world. So it really does leave you wondering, when a single poison is both a weapon of war and a common tool you can find on a shelf, who can ever really be safe from its shadow?